Yep, comes on everyone. Let's start off. The last thing we did was this. Great. So next thing, like I said, there are two main concepts in this. One was the Bernoulli's and one is the equation of continuity. We have four sub-concepts on this. One was the velocity of efflux. That is the most important one. Then is the Magnus effect and Venturi meter and siphon. So the last three are mostly theoretical. So velocity of efflux is the important one. So let's see this. So what is this velocity of efflux? So consider a container. Of cross-section area A with a hole of area small a at a depth h from the surface. So the container would look kind of like this. So we have a liquid. The area of the container is A. Here at the bottom, we have a hole. So let's say hole is here. So remember, h is not the height of the container. H is the depth of the hole from the surface. Getting it? So we are talking till here. So you can also say like this, h is the height of the liquid above the hole. So in this process, what will happen? The liquid will come out with some speed. So this is called velocity of efflux. So velocity of efflux is nothing but the speed of the water when you make a hole in a container carrying liquid. This is a hole of area smaller. So now we want to find what speed will the liquid come out. Others, do keep your cams on. So we have a liquid here. Now you need to understand how will this liquid actually flow like. So this is how the streamlines will be converging. Think of like this. After the movie gets over, did you ever see how people go? The exits are near the screen. So it's like this. Imagine this is the movie screen. People are sitting here, and after the movie gets over, they just open this door and people are out, right? How do people flow? Everyone is trying to converge near the door, isn't it? Can you visualize that? So people are literally trying to get out through that one small door, and the entire, this auditorium or the stage or the theater gets empty through that. Something of that sort. If you see all the streamlines right from the surface are converging at the hole and they're coming down, and the velocity at this point here is v1. So if you consider here, this is 0.1 and this is 0.2. So 0.1 is on the surface. 0.2 is just outside the hole. So the streamlines converge and they get out from there. And here the pressure at P1 and P2 will be equal to P0 because they're exposed to atmosphere. So first equation of continuity. Remember this area was A. The whole area was small a. Equation of continuity, A1 V1 is equal to A2 V2. So in this case, it will be AV1 and this is AV2. Then Bernoulli equation. Bernoulli equation is P1 plus rho GH1 plus half rho V1 square P2 rho GH2 plus half rho V2 square. And remember this height was H. So P1 is P naught, height is rho GH, velocity is half rho V1 square. P2 is also P naught, height is 0, that's the reference line, and this is half rho V2 square. P naught cancels. And from here you can get V1 is equal to AV2 by capital A. Substitute here. Rho gets cancelled. You end up with GH plus half A square V2 square by A square is equal to half V2 square. So if you simplify this, let me show you the answer on the next page. But have a look at the step still here. Any doubt so far? So we just use two things. Like, in entire fluid dynamics, if you ask me, there are only two concepts you have. One is the equation of continuity, one is the Bernoulli's theorem. I just used both of them. So all the liquid from the surface is getting out from the hole here, hole from here. So A1 V1 is equal to A2 V2. Clear. So if you simplify this, you end up with V2 is equal to root over 2GH by 1 minus A square by A square. Let me write it on the next page. So this is the result you need to remember. So velocity of efflux is given by root over 2GH by 1 minus A square by A square. Remember, H is not the height of the container. H is the height of the liquid above the hole. And again, this is derived when the pressure is P naught on the surface. So if you actually mess up few things, this formula is not valid. We will see those variations also. Now, if the hole is very small, that is, if the area becomes much greater than small m, then your A by A will tend to 0. Then your velocity of efflux, the formula becomes approximately root 2 GH, which is like freely falling body, isn't it? If you drop a particle from a height h, that would be the speed actually. So these are the two results. One is for a small hole and one is for an area is given. Until unless they mention in the question the hole is small, don't use root 2 GH. If they give you the area of the holes, right, and they ask you velocity, this was a question which they asked in my year 2006 mein. They gave that, the area of the hole, A by A ka ratio is 1 by 50. All right, and I thought like, yeah, it is so small, 50 times matlab it is very small, so I ignored it and I used V is equal to root 2 GH and I solved it and I got answer 50.5. And then when I looked at the options were 49.5, 50, 50.5 and 51. Now, if the answers are 40, 50, 60, 70, I wouldn't have cared. But when I saw a difference of 0.5, somewhere I was suspicious. I said, first of all, there was no point in giving this value, right? And second thing, answers are so close. I said, something is wrong. Let me use the normal formula. I used that actual formula, root 2 1 minus a square. Answer is actually 50. You get answer proper 50 if you use this formula. And that is the answer. Most of my friends did use root 2gh. They did goof up. So you have to be careful. So in the question, if it is mentioned small hole, then fine. Or else don't. Put it down. You copy it down. That's a useful one. And let me show you variations of this. Clear? Now, the variations. Now, there is literally, these things like each variation of whatever I'm showing you now will be literally, each one will be a question. It would be, yeah, root 2 GH. I forgot a root. Variations of velocity of a flux. Yeah, the only thing, this is only valid for small holes. All right, so what is this thing? So first of all, let's say if you have a container here, consider this point is 1, this is 2, and this is 3. 1 is on the surface, 2 and 3 are just inside and just outside the hole. Now the question is, right, can I say P2 is equal to P naught plus rho GH? Can I do this? You cannot do this. This formula was derived under the assumption the liquid is at rest, isn't it? But here, when you make a hole, the liquid is flowing out. So that means the liquid has actually acceleration. So P2 is not equal to P naught plus rho GH. Reason, since liquid is moving, do you remember how we derived it? We derived it like this. We said we took a cylinder, ऊपर से pressure P1, नीचे से pressure P2, this is mg, then we said acceleration is 0. But here, if the liquid is going down continuously, there is an acceleration, isn't it? That formula P naught plus rho GH was derived under the assumption liquid is at rest. That's why it's called fluid statics. So liquid is moving down with acceleration. But if you take small holes, AV1 is equal to AV3. V1 will be AV3 by A. This will tend to 0. A is much, much greater than A. So you can say the liquid is going out with a very small speed, right? So V1 tends to 0. Therefore, we can say acceleration also tends to 0. And therefore, we can say P2 is approximately P naught plus rho GH. There is still an error, but approximately it works out. So our formula becomes like this. So this is the thing. So the pressure difference P2 minus P3 is delta P. This is a pressure difference across the hole. So the velocity of a flux is given by root over 2 times and delta P by rho liquid coming out. I'll show you some variations. Remember, this is valid only for small holes. Quite a useful formula, saves you a lot of time. That should definitely mark up this. So that's your result. V is equal to 2 delta P by rho. Let me show you how that works. Yeah, you can say like that's what happens actually. Because the hole is small, right? It comes out. Speed is there. V2 may also V1, there's a speed, but negligible. Meaning, think of like this. It's like you are having something like 10 by 100 minus zero point 0.1, something like this. And you're saying it's okay, we'll just neglect it and we will just say it is 10. Something of that sort. That 1 minus small a by a square, that term goes off. Is the formula clear, everyone? 2 delta p by rho, which rho? The liquid coming out. Now look at the variations, how it works. The first one, what we derived normally. So we make a hole here, there is a liquid here. This is H here. This is P naught. This is a small hole. So what is the pressure here? P naught plus rho GH. What is the pressure here? P naught. So what is delta P? Rho GH. So what is the velocity of efflux formula? Root over 2 delta P by rho, which is 2GH. That's the standard one. Let me show another variation. Suppose if you have a container, let's say we have a liquid here. We have a different liquid here. Let's say this density is rho, height is h, this density is 2 rho, this height is 2h. Outside of the pressure is P naught, and let's say you make a hole here. Now can you find the velocity of efflux? Small hole. So two liquids. Suppose we have a piston here. We have a block M. This is a piston of area A. Filled with liquid here. This is a rho. This is H. Outside is P naught, and we have a hole here. Find the velocity of efflux. Now you can't use that formula root 2gh directly because these are derived under the assumption upper, it was P naught on the top. It is not. Suppose if you have a sealed container, we have a liquid here, and let's say this time the pressure is 3P naught here. This is H here, and this is rho here. You make a small hole here and B. The BCD each case is actually a mains level problem. Find the velocity of efflux. Get them all. I'll give you a minute. So if you know your formula, you will get the answers in like 30 seconds. 2 delta P by rho liquid coming out. Try. Another 30 seconds. Let's see. Look at this guy. Want the pressure here. What is the pressure? P naught plus the first liquid will give you rho g h. The second liquid will give you 2 rho g 2 h. What is the pressure outside? Pressure outside is P naught. So delta P will be 5 rho g h. So what is the velocity of flux? Root over 2 delta P by the liquid coming out. So it is 2 rho. So how much will that be? 2 will cancel. That would be root 5 gh. Sure. The rho liquid coming out. Why will the green liquid come out? The blue liquid comes out. So you should take the density of that. What is the pressure here? So here pressure is coming due to atmosphere P naught, then due to the block, that is weight by area, then due to the liquid rho gh. Outside the pressure is P naught. So from here we get delta P is mg by area plus rho gh. The velocity of efflux will be root over 2 into mg by area plus rho gh by rho. What about this guy? Here the pressure on the top will be 3p naught plus rho gh. Here the pressure is p naught. So delta P will be 2p naught plus rho gh. The velocity will be root over 2 times 2p naught plus rho gh by rho. Easy? Have a look at this. Ask me if you're confused. Clear, everyone? Sharman, Arush, Parth, clear with this? Ojas, can't see you, right? Niharika, clear? Jainil, Nikhil, Devansh. Let's see one more. Suppose if I give you like this, we have a test tube rotating with omega. This side is open. So pressure is P naught and this is filled with liquid. Length is L. You made a small hole here. So what will happen? Liquid will rush out with V. Neglect gravity. What is this? So literally fluid statics, may whichever case you saw to find pressure, everything you can pop up. What will be the answer for this guy? With what speed is the liquid coming out? You guys remember the result? Px minus p axis, the pressure difference in a rotating cylinder. Right, Vihan, that is velocity of efflux. But if I ask you this question, what is the velocity of the water coming out? Both are not same. So in case you guys forgot the result was this. Px minus p axis is rho omega square x square by 2. So we want the pressure here. Let's call it P1. So P1 axis is 0, P naught, which is rho omega square L square by 2. Outside the pressure is P naught. So this is your delta P, rho omega L square by 2. So velocity of efflux will be root over 2 delta P by rho, which is omega L. Perfect. But remember, this is your radial velocity. So what is actually happening? This guy is also going in a circle, isn't it? So if you are going in a circle, so this water jet is coming out V here. This is a V radial. This is the velocity of efflux. Plus also, it will also have a tangential speed now, which is also omega L. Efflux is also omega L. So the liquid is actually coming out at 45 degrees. Is that making sense? Imagine there is no hole. The liquid is going with what speed? R omega, isn't it? Now you made a hole. So liquid is being pushed out radially. So it has two speeds. It has a tangential speed and a radial speed. So speed of the liquid would be L omega root 2. I hope you're getting the difference. Because of the pressure, the liquid will try to come out like this. But because you're going in a circle, the liquid is also going tangentially. That liquid will have two different velocities. So resultant will be L omega root 2. So be careful. Velocity of efflux is different. Speed of the liquid coming out is different. Clear with that? So velocity of efflux is because of the difference in pressure with what speed you come out. Vihan, clear? Now this, you can make even a better variation of this. Suppose if you have a test tube with different liquids, let's say this is rho 1. Let's say this distance is x1. Then we have another liquid here, rho 2. This distance is x2. Again, all distances are from the axis. So on. Now let's say this liquid is rho n. This distance is xn. This is P naught. So here, now if you try to find the pressure difference, this will be P naught plus rho 1 omega square by 2. Rho 1 omega square. Delta P naught. P at x1 square minus 0 square. Plus rho 2 omega square by 2 x2 square minus x1 square. So on rho n omega square by 2 xn square minus xn minus 1 square. How did we get this? If you remember this rotating wala, in this integration, the limits will be what? First one will be 0 to x. Second limits will be x1 to x2, no? You're getting it? When you take the limits, pressure difference from x1 to x2 will be what? x2 square minus x1 square. Then limits will be x2 to x3. Then the limits will be x3 to x4 and so on. Are you getting it? So that pressure difference will keep on adding there. So we will get like this. And delta P will be P minus P naught. And the velocity of efflux will be root over 2 delta P by rho n, the liquid coming out. You can actually refer this, page 50. So there you can see the limits change in integration. So for each liquid you keep on integrating, you'll get this. So if you have multiple liquids in a cylinder, that's what you do. Have a look at this. Clear. Let's see a question. Let's say we have a container. We have a piston, 10 centimeter square. We have a fluid ρ1, which is 1000 kg per meter cube. 10 meters. Pressure is 3 P naught. We have a second liquid ρ2, which is 3000 kg per meter cube. This height was 20 meters. And here you have a block of 1 kg. Make it 10 kg. And here at the bottom, we have a small hole. Outside pressure is P naught. Find velocity of flux. There, I just literally combined BCD cases. Just numbers there. Hmm. Let's see. I'm interested in finding pressure here. So pressure P1 here is P naught, 3 P naught due to the gas, plus the block ka pressure will be mg by area, plus ρ1 GH1, plus ρ2 GH2. So 3 P naught is 3 into 10 power 5. mg is 100, area is 10 centimeter square, that is 10 into 10 power minus 4. This is 10 power 3 into 10 into 10 plus 3 into 10 power 3 into 10 into 20. You can take out 10 power 5 common, you'll end up with 3 plus 1 plus 1 plus 6. That is 11 into 10 power 5. That's P1. So delta P is P1 minus P naught, which is 10 into 10 power 5. Velocity of efflux will be root over 2 delta P by root 2, which is 2 into 10 power 6 by 3 into 10 power 3. That would be 10 power 3, so 10 root 20 by 3. You can further simplify it. You can take out the 2 also common there. You'll get 20 root over 5 by 3. Yeah, there's nothing there. You just need to put the numbers there and finish it off. Check. Clear? Did I mess up any calculations? Clear, no? Next one. So we have a container on a platform filled with liquid. This height is 2h. This height is h. You made a small hole here at a height x from the top. So liquid from here will go and fall on the ground. This is your range. Find x for maximum range. So depending on where you make the hole, you get water at different levels. If you make the hole here, it'll fall here. If you make the hole here, it'll fall here. So there is a particular value of x where you get a maximum range. See, if you make the hole on the top, you get more time, but you'll get less velocity. If you make the hole at the bottom, you get more speed, but less time. So there is a compromise. So where should we make the hole? It's a small hole, so you can use root 2gh. So if you see, once you say v is equal to root 2gh, fluid mechanics is over, it is kinematics. So first thing, what is the velocity of efflux? So V is equal to root over 2gx. Remember, h is the height of the liquid above the hole. What is the time of flight? Time of flight will be root over 2. This will be, how much is this guy? This guy will be 3h minus x. 2 into 3h minus x by g. So the whole question has become like someone is throwing a particle horizontally from a building of height this. So from here we get range is Vt. G will cancel, 2 will come out. You end up with root over x into 3h minus x. We need to maximize this function. So dy dx of 3hx minus x square will be 3h minus 2x is equal to 0. So at x is equal to 3h by 2, we get maximum range. So if you actually think about it, it is actually the center of the whole system, isn't it? From the top to bottom, you make a hole at the center. So you can generalize this function. So if you have a container like this placed on a support, if this height is h1 and this height is h2, the hole, right, for the maximum range, let's say x from the bottom, so for max range, x is equal to h1 plus h2 by 2 if h1 is greater than h2. X will be h2 if h1 is less than h2. What do you mean by that? See. Example. If this was 2h and this was h, where is the midpoint? 3h by 2. That is okay. But if I take the reverse, now where is 3h by 2? The midpoint, right? Now you need to understand max doesn't care. For max, it is simply a function, isn't it? When you differentiated this, you're asking what is the maximum value of x ka value for maximum r. So max doesn't know what you're talking about. So max is telling you if you make a hole here, you'll get maximum range. But does it even make sense? There's no container there to make a hole. So what's the next best point? The closest point here, isn't it? If you can't make a hole at the center, then the closest point to the center is what? The bottommost one. So for maximum range, you should put it here. Is that making sense, everyone? Mathematically, the function says mid, but mid में container तो होना चाहिए ना to make a hole. Clear with that? So that is one. Another kind of questions, right? Suppose if the container is on the ground, if you make a hole from the top, let's say here x, or if you make a hole from the bottom, let's say x, you will observe you get the same range. And if you make the hole exactly at the center, maximum range. Again, you can see this clearly mathematically. So when you take the hole from the top, velocity will be root 2 gx. Time of flight will be root over 2h minus x by g. If you take the hole from the bottom, velocity will be 2 root 2 gh minus x. Time of flight will be root over 2x by g. So when you multiply, can you see you'll get the same function? So the thing is this, if the hole is on the top, you get less speed, but you get more time of flight. If the hole is at the bottom, you get more speed but less time of flight. So the product will be same. Clear with this? So you get the same range if you make a hole from the top and the bottom if you're on the ground level. Have a look at this. Next one. Easy. The only thing you did is root 2GH, isn't it? कुछ नहीं था. Everything else was kinematics after that. Let's say we have a container, but this time the hole is like this. Let's say this was 40 meters. Make it 20 meters. And make this फर्क नहीं पड़ेगा. Make it 10 meters. Small hole. Find range. This angle is 60 degrees. So the speed root 2GH actually doesn't depend on how you keep that hole, so it won't matter. So this is the hole of area A is equal to root over 399 by 400A. It is actually, hole is actually pretty big. And let's say this is 10 meters. Find velocity of flux. Get them. Again, they're just formula based and little kinematics. Twenty root 3. You got such a good range. I hope you didn't use u square sine 2 theta by g. Did you do that by any chance? You are throwing from a height. You can't use a regular range ka formula. Arnav, so far clear? Yeah, give it a try. Give it a try. Everyone should try 10 into root 3 plus root 5. Okay, that could be possible. I was expecting something weird like that. I could be wrong. But I'll give you another minute. Then I'll show you the 39A part. B is easy. Just formula में डाल दो root 2GH that 1 minus a square by a square. Root 3 plus root 5. Okay. Did you multiply with the UX? Oh, after that, you got root 3 plus root 5. Okay. Let's see. So this will be velocity v is equal to root 2 gh because the hole is small. This is 20 into 20. You're coming out with 20 meters per second. So the question has become like there is a building of height 10 meters and someone is projecting with speed of 20 meters per second at an angle of 60 degrees. We can use Sy is equal to Uy. So when you're throwing from the building, the vertical height is what matters, half A by T square. Sy is minus 10. Uy is 20 sine 60, so that's 10 root 3t. Ay is g, so minus 5t square. Minus 2, 2 root 3t minus t square. T square minus 2 root 3t minus 2 is equal to 0. T is equal to 2 root 3 plus minus root over b square. That is 4, 3, 12 plus 8, 4ac by 2. So that is root 3 plus 20 is root 5. So range will be ux into time of flight. Ux is u cos 60, which is 10. Check. Clear? Next one. Like I said, once you got the velocity, there's nothing there. It's pure kinematics. This also, there's nothing there. V is equal to root over 2gh by 1 minus a square by capital A square. This is 2 into 10 by 1 minus 399 by 400. That would be 200 root 2. बस डायरेक्ट फॉर्मूला सब्स्टिट्यूट नहीं डाला. Clear idea? Easy. Next one. Next one. We have a container. We have a small hole. This area is a fully filled with liquid. Height is h. This is placed on a platform of height h. This is a small hole of area small a. Somewhere here you kept a bucket. You kept a container whose width is h. You can neglect the height, and this distance is h by 2. Now see, the moment you make a hole here, what will happen? The liquid will overshoot like this. Then what will happen? The liquid level will decrease. Then the liquid will fall into the container. Then the liquid level will decrease even more. Then the liquid will fall into the container. Then the liquid will decrease more. Then the liquid will be like this. Isn't this how it will fall? As the water level decreases, the water jet becomes slow. It comes closer and closer. So that means water will fall into the bucket for some time. Isn't it? So it was something. First, it will overshoot. Then it falls into the container. Then it falls into the container. Then it stops falling into the container. This is how the scenario is going. As the height of the liquid level decreases, the range decreases. So the first question, how much volume of liquid is collected in the bucket or container? Second one, find the height of the liquid at time t. Meaning after some time, the diagram would become like this. The liquid is only till here. So I wanted to find this excess function of time t. Hole is small, but area is given. But it is mentioned it is small, so you can use a root 2gh. Get these two questions. If it is a paragraph, I'll ask you this. B is the most important one if you ask me. A is also good. A is intuitive, but B ka result is more important. Let's get the first one. I'll give you 2-3 minutes for the first one. But is the question clear? Initially, the liquid will overshoot, then the liquid will come closer, so it will fall in the bucket for some time. So how much water gets collected in the bucket? You can neglect the height of the bucket. So there is no need to integrate. For the first one, there is no need to integrate. I think I'll give a minute more. Right, Poroja, he got it. We have one answer, everyone. Get the second one now. You guys are able to hear me? I lost power, so someone just reply on the mic. I can't see you on the screen.
Yes, so we can hear you.
Okay, good then. Let's see what happened. Yeah, the entire building, the power is lost. Okay. Anyone got the answer for the first one? Let's see. Able to hear me now, Vihan?
Yes, sir.
Okay. Let's see how to do the first part. So the catch in the first part, you don't need actually integration. Think of like this. So as the liquid level is falling at a particular height, let's say H1, the liquid will hit the right edge of the container for the first time. I didn't draw it properly, but this is the first time you'll hit it. Now, as the liquid level goes down at a new height, H2, the liquid will hit this side of the container too. So can I say from this argument, all the liquid between H1 and H2 will be inside the container? Is that making sense? Pratik? Roja, clear with this?
Yes.
So simply what I need to find, when the height is H1, the range is 3h by 2. When the height is H2, the range is h by 2. So from there I can get H1 and H2. So we know the velocity v will be root over, let's say 2gx, x is the height. So time of flight will be root over 2h by g, the whole height is constant. So therefore range is equal to vt, which is root over, g gets cancelled, 2 root xh. This is the range. So to get the range of 3h by 2, so for h1, the range is 3h by 2, which is 2 root xh. Square on both sides, you end up with xh1 to h1h. So we get h1 is equal to 9h by 16. So when the height of the liquid is h2, the range is h by 2, which is root over 2h2h. h2 is h by 16. So all the liquid between h1 and h2 is in container. So therefore the volume collected will be A into h1 minus h2, which is AH by 2. So literally half of the liquid is in the container. Just have a look at this. Is this clear, everyone? Clear? So that's the first part. Question still not over. What is the second part? You need to find the height as a function of time t. Have a look at this.
Recording in progress.
Clear with this? Clear, right? Yeah. Opt-in from this thing. Yeah, better. What is the next one? How to do the next one? Any answers? Nikhil? Soham? Sharman? I'm looking you guys in my phone now. You all are looking so small in the phone. This is hopeless when the power goes off. I don't know when this will come. Let's see. Till my tablet ka battery dies down, we'll put a fight. And we still have 73%. I think we should be able to survive. So how to get the time? Let me know in case you can't see the screen, you can't hear my voice. Let me know because I'm little. My desktop is gone. That looks pretty weird. How to find the time? Now listen. This part involves integration. And this is how we always do, right? Whenever we integrate, we always start from the intermediate position. So after time t, let the height of the liquid be x. I'm unable to see your messages, so do unmute your mic and ask me if you have any queries. So after time t, let the height be x. And let liquid level decrease by dx in time dt. So we are assuming this small amount of liquid decreases by dx. In this process, you're going out with velocity, which is root 2 gx. Is that making sense, everyone? So whatever liquid level decreases here, all this liquid must have gone, same amount of liquid must have gone from the hole, from the bottom. So volume flow per second, we studied as an equation of continuity. So volume per second is area into velocity. This comes from equation of continuity. So how much is the volume that is flowing out? A into dx, that is the volume, minus sign, by dt is A into V, the negative sign because x is decreasing. So how much volume decreased in time? So A dx decreased in dt time. So you end up with minus A dx by dt is equal to A into root 2 gx. So this guy will be dx by root x minus A by A root 2 g dt. Integration 0 to time. When t is 0, height is h and this is x. This guy is 2 root x. Limits will go from h to x. Minus A by A root 2 g t. If you simplify, we will get root x. . X. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . minus a by a root over g by 2 into time. You should definitely mug up this result. It would be a straightforward question where x is the height at time t, h is the initial height. H is the initial height and x is the height at time t. There. Copy down the formula. You will need that result. Any doubts on this? Yeah. Now see in this, how the last questions? Clear na Arya? Ignajit? Arnav? So in this, the first kind of question, I'll just write on the formula again. So root x is equal to root h minus a by a root over g by 2 time. So they'll ask you like this. Time taken to empty the tank. So if you want to empty the tank, that is x must be equal to 0. So we get 0 is equal to root h minus a by a root over g by 2 time. So we get time is equal to root over 2h by g a by a. You'll notice something. So t is proportional to root h. It's not a linear function. So example, this would be like a mains level question. So if you have one tank and if you have another tank, let's say this height is 4h and this height is h. So time taken to empty, if this is T1 and this is T2, then we get T1 is to T2 will be 1:2 ratio. So if you make the height 4 times, you will get the time will be 2 times. It will not get 4 times. Is this clear, everyone? I was just shopping a lot today. Right? You're not able to hear me? Anyone there?
Yes, sir.
Okay. Then the second part of this, Suppose if I ask you like this, so if you have a tank here, find the ratio of time to empty first half and the second half. There, my desktop is back online. I can see you guys, so great. Find the ratio of time to empty upper half and the lower half. This would be another good question. Meaning like this, let's say we have a tank. This is height h. After some time, the tank becomes half empty. So this guy is h by 2. Then it becomes fully empty. So from here to here, time is t1. From here to here, time is t2. So find t1 by t2. This will be a good question. Let's get this. Is the question clear, everyone? You will need that result though. Root x, this thing. So in this, they can ask you so many things. How much time will it take to empty the upper half and the lower half? 1 by root 2 minus 1. Now ask yourself, Puraja, which will be more time or less time? Will the upper half empty first or the lower half empty first? When is the speed more? Initially or finally? Initially, that means T1 must be smaller than T2, na? So T1 by T2 must be less than 1. That much we can figure out. Try. I'll give another 30-40 seconds. Parth, give it a try. Everyone should try. Instead of playing with your fingers and breaking your knuckles and all, you should focus and solve problems. Because right now it might feel a little difficult and all, but next year at the same time, your mains results will be out by now. All right, and you don't want to be in that position. Then there is no point in sitting and regretting like, yaar, thoda fight karna chahiye. So whenever you feel like not studying, right, just visualize, this thing. Visualize yourself in 3 situations. How will you react if you got a percentile of 99.5? How will you react if your percentile is 98? How will you react if your percentile is 95? How will you react if your percentile is 85? That is the best way to visualize. And then get back to work. Getting it? This guy is gone. 85 guy is completely gone. 95 guy is crying. 98 guy is confused. Right? At least 99 percentile, if you don't get, you are out of the game. Anyways, we'll be having this discussion next week. We'll have a PTM. Right, Ishana. Puruj, I think you just need to reverse calculate. So how do we get this thing? See. So for the first half, so root h by 2 is equal to root h minus a by a root g by 2 t1. 0 is equal to root h minus a by a root g by 2. This is t. This is to empty the tank. So can I say T2 is nothing but the time taken to empty the tank minus T1? ऐसा भी कर सकते हो. Or you can do this way also. You can take the height is h by 2 for the second one, na? That also would work, right? If you want to do that, it will be like this scenario. So this is h by 2. You're asking like this. So your formula will be root over 0 is equal to root over h by 2 minus a by root over g by 2 t2. This also fine. Making sense? So h was the initial height, isn't it? So you start the problem from h by 2. So your initial height is h by 2. So if you take t1 by t2, you will get root 2 minus 1. You can check. Is this clear, everyone? Clear? So there, that is one. Take a break. Come back by 7 to we'll continue from here. It's a good problem. It has a lot of things in this. So any doubt so far, you can ask me. Or take a break, come back in 10 minutes. Any doubt so far? Okay, come back in 10 minutes. Now, same question. Let's see variations of it. Suppose if I similar question, but we will do a small change. So we have the container. This is a small hole. Area A. This area is A. So now we have a tap. So in the previous case, there's only liquid, right? Now from the tap, the liquid is coming out at a rate of Q meter cube per second. So as the liquid accumulates here, the liquid is also leaking out. You're getting how is the story? You took an empty container with a small hole and then you opened the tap, and every second you're getting this much liquid into this, and the liquid is leaking out. So liquid flows out from the tap at a rate of Q meters cube per second. So this and the previous question got difference. In the previous one, the liquid is already there. Now here, liquid is coming from somewhere. So there's an inflow and an outflow. Liquid flows out from the tap at a rate of Q meter cube per second into an empty container. First one, find the height of the liquid at time t. If they ask you, this becomes an advanced question. But if I want to ask you just at a mains level, find the maximum height. Something happens. The liquid will reach a certain height and stop. And approximately plot height versus time graph. So how is the height of the liquid changing with time? Is the question clear, everyone? How will we do this? Anyone not clear with the question, please ask me. Get me the mathematical equation. The max part is fine. The integration that you get is fine, that you will be able to handle. Get the first part. Why are you giving the second part? You are the type of person, who go to the Pizza Hut, eat all the toppings, and then leave the bread and come. वही करते ना फ्रेंड्स के साथ जाएंगे तो there's a pizza, so you eat all the cheese and all the toppings and leave the bread and come. Do the first part. Second part, I said, no, it's the main one. That is okay. let's say the mathematical equation. See, this is what I keep on telling you. You should be able to get that mathematical form. Advanced may, that is what they'll expect from you. It's not about solving. Solving is fine. If you're unable to figure out how to get the mathematical from this given data, we have a problem. Means ho jayega. Advanced may, you will get stuck. You will get stuck very badly. Half the questions will be of that sort only. So you need to figure it out. It's okay if you don't get it right now, but like I'm saying, right, you should have an idea, like, think about it. Till now, in all the integration problems, by now you must have got a theme, right? How do you always start? After time t, let the liquid level be x. ये start करते हैं ना, हर बार वही करते हैं. Every time we do that. And then what we say, in a small time dt, let it change by dx. And this is not the first time. You have seen this before also. You have seen this multiple times in multiple chapters. You need to grasp that. Problem क्या होता है ना, you just listen at that point and leave it, and you think it's only belonging to that chapter. Where you have seen this question, yaad hai? In time dt, let the ice thickness be x, and in time dt, let the thickness be a dx. Remember this question? Formation of ice on this thing. It was based on that. Similar it was. मतलब यहाँ पे ice formation था, यहाँ पे water was leaking. You have seen something. So this is one thing you need to understand. Whatever I'm teaching you, right, nothing will come into the advanced directly, but you will see similar concepts and similar models. So if you're unable to relate stuff, you will have a problem. So that's what I keep telling you. If the problem is hard, it is okay. Spend some time, right? Maybe spend today 6-7 minutes. If you're not getting it next day, spend 5-6 minutes. Not getting next day again, spend 5-6 minutes. It is worth it. Spend at least 2-3 days, 6-7 minutes on 3 different days. You're still not getting, we are there. I'm there. So come back, help me, I'll help you out. Because every time, you will just try the question for 4-5 minutes and you'll come and say, I didn't get it. I'll give you the answer. You are happy, but trust me, you didn't learn anything. The reason why you find advanced question stuff is because you are not fighting with them enough. And आप लोग क्या सोचते हैं पता है? Fighting मतलब you think you will sit in one day and you will spend 45 minutes on the question. That is useless. If you can't figure out what to do in 6-7 minutes, you won't get any new ideas on that day. Leave it. Go to the next one. Try the next day. Trust me, next day morning when you are doing brush or when you're eating breakfast or when you are walking, doing something, suddenly it clicks. यार उसमें ऐसा भी कर सकता था मैं. You will get some thought, right or wrong. That's a different story. Then you go and try again second day. Getting it. This is important if you are serious about learning. That is the difference between in problem. Can I tell you what? You guys have a lot of access to answers. रे. कुछ समझ में नहीं आया, Google में चले जाएंगे, आंसर देख लेंगे. The difference between you guys and when we prepared, right, we didn't have solutions. Trust me, I solved Erudo half of the book while traveling in bus. Every day it used to take me 45 minutes one way while going and 45 minutes while coming back. So 90 minutes. I never used to get a seat to sit also. The bus used to be a rush. So what I used to do from Eridona, I used to take a piece of paper, write down 2 questions on the paper and put it in the pocket. So while going in the bus, while standing, I used to look at the question. There is no pen, no, there's no paper. I just have to look at the question and in the mind, I have to write the steps and solve. It looks difficult and impossible, but after 3 months, 4 months, you'll find it is normal. I started writing with my finger in air. I do that. And you should see my calculation speed is immense. I can think of at least 4 to 5 steps. If the problem is really complicated, I keep the steps in my head. Once I reach home, I take a paper and solve it. Trust me, I solved half of the Erudo like that while traveling in the bus while standing. I'm not saying I'm a super genius. 90 minutes kuch kaam hi nahi tha. I didn't have Instagram. I didn't have PUBG. Right? I didn't have Facebook. I didn't have YouTube. I don't have a mobile phone. So what do? You're bored, right? So I started solving questions. And not much. Maybe in that entire day of 90 minutes, I must have solved barely 1 question or 2 questions per day. Bus. But what happened was I was thinking deeply about each question. You guys think this way. You think like, you'll sit for 1 hour on a day and do 1 question. That is useless. Don't do that. Spend multiple days, 2-3 days. It takes time, for the subject to get absorbed. If a student comes and tells me, sir, I did 20 questions today, 20 tomorrow, 20 next day, 20 next day, 20 next day. Someone comes and tells me, sir, I did 100 questions on Friday. This guy is useless. You guys take pride in that. You think one day mein 100 kar liya. You take pride in that. That is useless actually. You are cramming so much material into your head, you're not giving time to solve. Only for your ego boost, you're solving 100 questions in a day. Instead of doing 20 questions every day, when you do this 20 questions, you will get 4-5 doubts. You have time. You will think aram se like, yaar, why am I not getting? You can ask the teacher next day. You are actually learning. But when you do 100 questions in a day, right, you are only obsessed about somehow completing the questions. You're not thinking, right? Ab socho na. 100 questions you have to do. You're at 29th question and you're not getting it. You're getting stuck on the 29th question. Will you think about the question or will you think about, hey, abhi bhi 70 questions baki hai? Half the time you're thinking, abhi bhi 70 questions baki hai and this stupid question is not coming. Did you see what you're doing? You're cursing the question. You are getting irritated and frustrated rather than actually spending and thinking about the question. So you guys really need to change the way you think. That is one. Second thing, when you don't get a question, right? Most of you don't write it on a paper. You know, there is a question there, you scribble here 2 lines and you think mujhe question nahi aa raha hai. When you don't get a question, you should take a paper and write the steps properly. Then you will see what you are missing. When you scribble something on a paper, you don't understand. See, if you're getting a question, it is okay, scribble. But when not getting a question, shouldn't you write it properly? You should respect the question. When you're not getting a question, the question is telling you, boss, there is something here to learn. And you don't want to respect it. You want to scribble on a small paper, which you don't even understand yourself after some time. So you don't respect the question. The question doesn't give a damn about you. You won't learn anything. And you think you tried. Slow down a bit, Ray. Getting it? I don't want a student who will do 300 questions in a chapter. Do 120, but अच्छे से कर. Do some quality questions. Anyway, so let's see this thing. So think about what I said. These are important things. You guys are much more smarter than my generation. There is no doubt about it. Only problem, the way you study is wrong. हमको स्विगी जैसा सब चीज 10 मिनट में आ जाना चाहिए. That's the problem. So after time t, let the liquid be by now this statement, how many times I must have told you? Let it be after time t, after time t, after distance x. We keep doing this. So let the liquid level rise by dx. This was x. So what is the inflow here? So volume, and this is a hole here. So liquid is coming out with root 2 gx. And from here we are getting at a rate of q meter cube per second. So volume per second is inflow minus inflow per second minus outflow per second. Bus, this is the catch. The net volume that is increasing per second is inflow minus outflow per second. Make sense? If you write this statement, physics is over. What is the mathematical part? Kitna volume increase हो रहा है? ADX. Kitna time में increase हो रहा है? TT में. What is the inflow? Q. What is the outflow? Area into velocity. Isn't this the equation? Simple logic there. We are not doing any hi-fi science here. If every second 10 liters is coming in and 3 liters is going out, the balance is 7 liters. बस इतना ही था. So this guy is A dx by dt. This is Q minus A root 2 gx. Physics got over. So this integration is a mess. That's a different story though. But once they teach you in maths, this is a joke actually. Root 2 gx. This guy will be dt by A. Integrate. This will go from 0 to t and this will go from 0 to x. Right? So if I actually try to integrate this, I'll just show you a few steps. You can simplify it further. We have to use a method called integration by substitution. We put 2gx is equal to t square. Let's put z square. T already used kar raha hai. Differentiate this. 2g dx is equal to 2z dz. So if you substitute here, dx will become z dz by g and denominator becomes q minus a z square z. Then you write this thing as z can be written as multiply and divide by a minus 1 by ag. This will be az dz by q minus az. Here also now multiply minus q and plus q. Minus here. Add plus q and add minus q. So this is a method they will teach you in max. This is minus 1 by ag integral, so that q minus az will cancel. So 1 minus q by q minus az into dz. So this is 1 minus g integral dz minus integral q dz by q minus az. So minus 1 by ag, this is z minus q ln q minus az by minus a. So you get something of this sort, and then substitute z there, you'll get the answer. So I will leave it there, but this is how you do. Clear? Now this is not a tough part. Okay, max when they teach you integration, this will look like a joke. So don't worry about that thing. Did you get the equation till here? If you got till here, your job's done. That's what you should be bothered about. That integration is like a small puppy. Max they will teach you to Godzilla's. So don't worry about that part. So from here, you'll get extra value. I will leave it there. Is that clear? The second part, how to find the maximum height. Like I said, that's an easy equation. Think about it. Initially, what is the height? 0. So how much liquid will go out? 0. So inflow is there, but there is no outflow. So 10 liters is coming in, 0 is going out. So kya hoga? Height will increase. If height increases, what will happen? Speed will increase. So 10 liters is coming out, 1 liter is going out. So height will still increase. So 10 liter will go out, 3 liters will go out. Height will still increase. 10 in, 7 out. Height will still increase. 10 in, 10 out. At one point, you will reach such a height where inflow becomes equal to outflow. At this point, liquid cannot increase anymore, isn't it? You reached a maximum height. Bas itna hi tha. So that was the second part. That's why there's a mains question. You'll get it in one step. So when the liquid reaches a maximum height, inflow becomes equal to outflow. The height is not increasing anymore. You reached a height. So Q is equal to A into V. V is nothing but A into root over 2G H max. Yeah, that's why there's a mains question. H max is equal to Q square by 2G A square. So from this logic, if you try to plot the graph, you will realize something. So initially the liquid height will increase, but eventually it will stop at H max. So the graph should look something of this sort. The function becomes like this. Is this clear, everyone? It increases till H max after some time and then it stops. Any doubts on this? All sure? No, same thing, similar one. Any doubts on this, what we did? So can you do this for me? Suppose similar question, just get the mathematical equation, solve nahi karenge. Suppose if this is a hemisphere. Filled with liquid, radius r, we have a small hole, area A, and it is leaking out. The question will be like this: find the time when the sphere is empty. Just write the equation and leave it. This is like that question, na? वो cylinder था. This was easy, you know why? Area is constant, na? यहाँ पे area is getting messed up, isn't it? Just write the equation and leave it. How will you do this question if they ask you? This would be an advanced one. This is how they'll ask. कैसे लिखेंगे इक्वेशन? No, normally I tell you one thing. When you see a question, don't you get a feeling boss इसमें integration है? You'll get that feel. You know, by now after practicing, you'll realize boss the area is changing. This is not looking like a normal one. The moment you know it is integration, you know the first step. After time t, this is the scenario. Draw the diagram. Try. I'll give you a minute. Just get me the equation. Solving part you can do it later. Did you get the equation? Yeah, don't worry about too many variables and all things that you will figure out. Let's see. There are multiple ways of writing this stuff. So let's say from here, if you take, so if you take this as origin, right? And if you take this as y, and if this is x, so I'm just taking downward. This is a liquid there. So in time dt, let the liquid level decrease by a small amount like this, dy. So this much liquid has gone out. So this much liquid is flowing out every second. This is dx, dy, and this is x. So volume flow per second is nothing but area into velocity. So what is the volume flow per second? Pi x square dy with a minus sign by dt a. And what is the velocity? Root 2 g. Now this height you're interested in, that is r minus y. Is that making sense? And we also know for equation of a circle, x square plus y square will be radius square hypotenuse, meaning Pythagoras theorem. So there I can eliminate that x square from here. So minus pi x square will be r square minus y square into dy, and bring that thing here, root over r minus y. This will be a into root 2g dt. This will go from 0 to t, and this will go from r to 0 because you want to empty the tank. Is that making sense of you? You can simplify this. You can write r square minus y as r plus y into r minus y. When you cancel the root, you will get something like root over r plus y into r minus 1 something. Then there's a way to integrate this thing. So don't worry about that part. Is this clear? At this point, it becomes a max problem. Understood this? This is one way they can ask you questions. Find the time taken to empty this. You can even take in terms of theta also. You can say this angle is theta and you can get in terms of theta. There are multiple ways to do this. So don't worry about that. Main idea is that the volume flow is that the area is changing. Next one. Let's say we have a bowl. We have a small hole area A. The bowl is filled with liquid And when the liquid leaks out, we find something interesting here. The liquid level actually goes down with a constant speed. Now think about it. When you take that cylindrical tank, when you take this one, and when you make a hole here, will the liquid go down faster or slower initially? The liquid will go down fast, no? And then slowly it will come down. So speed constant nahi tha. The liquid level is going out faster initially and slower later. But he's saying this shape is something special. It is observed the liquid level, when the liquid leaks from the hole, the level drops with a constant speed. Now, this does not happen for every shape. So what I want you to find, so this shape which is there, this bowl ka shape, find the equation of the bowl. If this is an integer question, they'll ask you like this: the equation of the bowl y is proportional to x power n. They'll say find n. That would become an integer question. Did you get the question? We got a bowl here with a small hole at the bottom. When it is filled with liquid and the liquid starts leaking, we observe the liquid level comes down at a constant rate. Technically, that should not have happened, but here something is happening there. Because see, what is happening, I'll tell you also. As the height decreases, speed decreases, but आपका area भी decrease हो रहा है ना? So less and less liquid is coming out. The area is also becoming smaller, so somehow it is compensating. The speed is remaining constant. Now, it looks scary, but it is solvable. You don't need integration. Try. I'll give you a minute. Right, Porosa. See, after time t, let this be x comma y and let this be 0 comma 0. So you're saying this thing here is coming down with u. So equation of continuity a1 v1 is a2 v2. So this guy is pi x square and velocity is u. This is a and v2 will be root 2 gy. Square on both sides. Pi square x power 4 u square is a into 2gy. Oh yeah, एक step answer था ये. So this is pi square u square by 2ag x power. Y is proportional to x power. Makes sense. So when the bowl is x power 4, this is not a parabola. Very good. How did we know area is pi x square? What is this coordinate? If this is origin, this is x comma y, मतलब क्या था? ये x है ना, God? So in a small time dt, this would be the thing na, which is leaking out.
Sir,
Whose radius is x and thickness is dy.
sir, how do we know it's a circle? That was my.
Hmm. Why didn't you ask me this question here? When you took a paraboloid, when you took this element, why didn't you ask me why this is a circle?
Sir,
अरे God, isn't X same for everything? क्या बात कर रहे हो? You mean to say from the center, the distance is not same for every point on the surface?
Okay.
If that is not a circle, then what it is? Or did I give you a shape like this? Then it won't be a circle. इतना clearly ऊपर दिख रहे circle. You hate circles, क्या? It could be. Some people, they could be like a racist or a circlist or something. You don't like circles. Happens. Clear with this. Next one. Now, for some reason, I never liked parabolas. So we have a container with a small hole. This is insulated. Outside is vacuum. This is a small hole. The container is filled with helium gas. Temperature is 1000 Kelvin. And you made a small hole. So the moment you make a hole, bahar vacuum hai na, what will happen? The gas will start leaking out. To find the speed of the gas just after the hole is made. Now, why just after? So we can make one assumption here. We can neglect any flow inside. Neglect the flow inside the container. That is, we are assuming the gas is at rest initially. Because after some time, what will happen? This gas inside will start moving. I can't find that velocity. Temperature will change. Pressure will get messed up. Everything changes. It becomes too difficult to figure out. Neglect the flow inside the container. That is, assume gas is at rest initially. Now, how do we do this? The moment I said this, did something strike you? I'm not even saying solve the question. Did something strike you? These are the things which you guys are missing. We say instinct, you see and you know something is there, right? And you should know that something is there. Meaning, abhi tak aisa question dekha nahi aapne, right? You never seen a question like this. I mean, 43 questions mein, did I talk about anywhere about a temperature, helium gas, and fluid dynamics? Until now, we never saw temperature, isn't it? In all the problems I taught you in velocity of efflux, you never saw temperature. So what's so different? So KTG is there. So what? If you had revised the notes, you would have seen something. There is a hint here. Where is that guy? The answer is here. Modified Bernoulli, remember? Once the gas comes out, what will be the temperature? Zero, right? Once the gas leaks into the vacuum, there is no temperature there. We can do one thing. इसका U by V लिख लेते हैं. Internal energy by volume. This is the formula we have to use, modified Bernoulli, because temperature of the gas is going to change now. So P plus rho GH plus half rho V square plus U by V. Now, if you don't know this, you won't be able to solve that problem. And how do you know how to use Bernoulli? Temperature is given. Outside is vacuum. So once the gas comes out, it will just spread to infinity. There is no temperature. Temperature of vacuum is undefined. Root 500 R. Interesting. I don't know. I don't think so. I don't know the answer. Let's see. Think I'll give you a minute now how to use that thing. So to use Bernoulli, you need to define state 1, state 2. So one is obviously inside, one is obviously outside. Done. Find the pressure. height is same, velocity, internal energy by volume. Try. Think whatever steps you can write. I'll give you 1 or 2 minutes. Let's see. So consider this is 1 and this is 2. You're going to apply Bernoulli between 1 and 2. The 1 is just inside. And 2 is outside. So we have to use the modified Bernoulli, P1. So the equation is this, P plus rho GH plus half rho V square plus internal energy by volume is constant. So initially pressure is P. I don't know how much is that. Height is 0. Velocity is 0 because you assume there is no flow inside. Internal energy F by 2 nRT, that comes from kTg by volume. Outside pressure is 0 because it is vacuum. Height is 0. Velocity is half rho V square. That's what we need to find. Internal energy is 0 because in vacuum there is no temperature, is not defined. Is that equation clear, everyone? Cross multiply, this guy will be P into volume plus F by 2 nRT. This will be half into rho into volume into V square. PV is nothing but nRT. So this will become nRT plus 1 by F by 2. Density into volume becomes mass. nRT, N is nothing but number of moles is what? Mass by molecular weight. This will be RT 2 plus F, the 2 will cancel. This will be mass into V square, mass goes off. You end up with V is equal to root over RT 2 plus F into molecular weight. For helium gas, F is 3, so that guy will be 5 RT by molecular weight. Remember RMS velocity, root 3 RT by M? कुछ ऐसा लग रहा है, it's not the same. So if you want to find the number numerical, this is 5, R is 8.3, temperature is 1000, by molecular weight is always remember in kg, 4 into 10 power minus 3 kg per mole. So 1000 comes out. That 4 also comes out. 2 comes out. Root over stuck by how much is that? 8 5 is 40. 41.5. So this is 500. And this is between somewhere between 6 and 7. So somewhere close to 3 kilometer per second ko upar hai answer. So root 41.5. I don't know, I'm guessing 3.2 kilometer per second. 1000 comes out directly, right? Huh? Is this clear, everyone? 41.5 you can actually calculate 41 का root 40 का root if 40 भी लिया तो 10 root 3 आएगा. That's around 2 will come out. That is 3. That is 6. 3 का ऊपर तो है answer definitely. Clear with this? There, you got a number there. This is how you do in case temperature is involved. Modified Bernoulli. Without this, you won't be able to solve. Clear? Got this? So that is one more model there. That is a bit about velocity of flux, the variations, especially if you see the last 3-4 problems based on integration. You should definitely know them. Because see, integration, when I can keep giving you a lot of variations. I can give you there is a cone, time taken to empty. I can give you hemisphere, time taken to empty. You can play around. In all the cases, you should just know how to start with that. The second concept is Magnus effect. This thing has more practical applications. So what happens is, if you take 2 points, so P plus rho g h plus half rho v square is constant. So if we consider 2 points at same height, just give me a minute. Same height, then what will happen? H will be same. Then you'll get P rho gh will be gone. P plus half rho v square is equal to constant. So from here you can clearly see that means if the speed is more, pressure is less. And to be more precise, pressure in the surrounding decreases. This might look a little counterintuitive like, because we consider this with the water jet, remember? Force was rho a v square. But you need to understand something there. There, the water jet was hitting the wall and stopping. Here it is not that way. What the statement says is, if the wind is blowing in a region, the surrounding pressure drops. Why is that happening? You need to ask yourself, what is pressure? Remember, how did we define pressure? When you put a body in a liquid or a fluid, the molecules collide with the surface, and that force per unit area is called pressure, isn't it? Now think about it. If you have a liquid which is going slowly, if you take a slow moving fluid, and now if you just observe the molecules, since you're going slowly, you have more time to collide with the surface. You're going slower. So you have more collisions. So there are more collisions. Therefore, there is more pressure. You're getting it. The liquid is not stopping. If the liquid hits the wall and stops, definitely you'll have more force. But the liquid is not stopping. Liquid is going. More pressure. Getting it? Think of like this. You want to slap your friend, right? Your friend is standing there. You tell me in which case can you slap him better? While standing in front of him at rest and beating him, or while you are running and trying to slap him? Making sense? In the first case, you get a better grip. You can beat him right and left multiple times. But if you're running, you can maybe hit him once or twice. But if it's the same thing, if it is a fast moving fluid, the molecules, because they're going pretty fast, there will be something of this sort. Collisions decrease. Is this making sense, everyone? I'll give you examples also. So if I have to give you a thing like this, suppose if you have a pipe like this, and if you have streamlines flowing like this, so if you consider this point as 1 and this point is 2, clearly we know V2 is greater than V1, velocity of flux. Therefore, you can say pressure P2 is less than P1. So at that thinner section, the pressure is lesser compared to the thicker section. Is this clear, everyone? Now, if you take few examples, one of the best example, you see this in your house only, calendar. When you switch on the fan, did you ever observe the calendar actually flies? So if you have a wall like this, if you have your fan here, now when the wind is blowing like this, if you see common sense, it feels like, it should stick, isn't it? The calendar should stick to the wall, but you will notice the calendar actually flies up. Reason? If you take this point 1 and this point 2, the velocity v2 is greater than v1. Therefore, p1 is greater than p2. The calendar gets pushed from the bottom. This you'll notice also, when the wind is blowing and the huts blow off. If you have a hut or something there, when the wind is blowing like pretty fast. So if you consider the same thing here, so if this is point 1 and this is point 2, same thing, v2 is greater than v1, therefore p1 is greater than p2. So pressure inside the house is more than outside, the hut blows off. Suppose if you have seen racing cars also, if you see they have some unique design, that doesn't look like a car, but let's assume it is a car. So now when the wind is blowing, what they do, right? They design in such a way, the wind going under the car and the wind going above the car, they have different speeds. Can you tell me which one should be more? So from under the car, V2 is going, above the car, V1 is going. Which one should be more? Ask yourself, you want the car to fly or car to be on the ground? That's the first question, right? You want the car to be on the ground. That means if you take this point here, pressure P1, and this point here, P2, which one should be more? You want pressure P1 to be more. So P1 must be greater than P2 for stability. So the car is getting pushed down more. Therefore, velocity V1 must be less than V2. So under the car, the wind is flowing faster than above the car. So you have to take care of aerodynamics. In normal regular car, it is not a problem, but F1 cars are going so fast that difference in speed will make this like an aeroplane. And this thing actually has an advantage. Now think about it. If P1 is more, means it is pushing the ground, car to the ground. So normal reaction increases, you get more friction. The car gets a better traction. Making sense? Now, if I go further, if you look at a artery, a blocked artery, so you will see the artery got blocked. And now when the blood flows through this, because of that blockage there, the speed increases. V2 is greater than V1, so P2 is less than P1. So what happens, right? So if you look at the artery there, so from outside, the blood pressure is pushing with P0 and P0. The artery is trying to push inside with P2. So as the blockage increases, the thing gets constricted. Now, most people, what they think, if there's a blockage, they will think the pipe will, the artery will burst or the something will happen. Actually, the reverse happens. Because the outside pressure is more, P0 becomes greater than P2. What will happen is something of this sort. The artery collapses. It gets pinched. And if this happens in a coronary artery, which supplies blood to the heart, that's what we call as a heart attack. You're getting it? So that is the reason, think about it. Suppose if the artery is going to burst, shouldn't you put the stent outside the artery? But if you actually observe, they keep the stent inside. You want the artery to support from inside. Normally, what happens with arteries also, right? They have a certain flexibility. So they do stop from collapsing. But then what happens, right? At some point, right, there's too much calcium deposits or something, arteries actually kind of become brittle. They lose that elasticity and they collapse. So if someone is having heart issues, right, it just doesn't come in a day or a week. It must have going on for years. It takes time for things to get damaged to that extent. But this is what happens in a heart attack. Clear with this? And this is how much it goes. And medical people think physics is waste to study. And these people become doctors like that without understanding what the hell is happening. That's what I keep telling them. Don't become dangerous doctors. So if I go further, if you take a ball, if you give velocity v, and this time you give the spin omega also. Now this ball at the top will have a speed v plus r omega. At the bottom we have v minus r omega. So if you take p1 and p2, you can clearly see speed is less here. So p2 is greater than p1. So this ball gets an push upward. So the ball, instead of going straight, it goes up. It gets a lift upward. You must have played football anytime. You must have noticed it. Sometimes it goes over the goalpost. In football, ever heard about this thing, banana shot? So there is something called a banana shot. So this is a goalkeeper, na? So what will happen in that penalty shot or something? So people are standing in front of the goalpost. So what these people do, you kick the ball, it goes like this. It turns around them. It looks like a banana. It's called a banana shot. So the concept is this. What they do, instead of kicking in the center, you kick somewhere here. So now what you're doing, you're giving velocity v this way and you're giving omega this way. You're giving a horizontal omega. तो अभी speed क्या होगा? At this point, the speed is v minus r omega. I think you should kick it here. Then you're rotating this way. So here the speed will be v minus r omega. Here the speed will be v plus r omega. And the pressure P2 and P1, this pressure is more. So this ball is going this way, but the force is acting this way. So the ball takes a turn. You're getting it? You don't kick in the center. You kick somewhere to the little to the left. You make the ball spin horizontally with omega, but go forward with velocity v. This is called a banana shot. So that is there. And this is also used by ants. Ever seen an ant ka hill? That ants make, that hill on the top, termites and all. Movies mein they show na snake stays inside, you put milk and the snake comes out. That is bullshit thing, but you must have seen that. That is actually not snake ka nest. It is actually termite or ant ka nest. Sometimes snakes just take, a break there. That's it. They don't actually stay inside. Unfortunately, after Diwali, right, there is a festival called Nagal Chauthi. I don't know what they call it in Hindi. They go to a snake nest, they put eggs and milk and all. Do they do that in Mumbai? So Vishakhapatnam, it is there. Getting it? After Diwali gets over, right, 6th or 5th day, there is a festival called Nagal Chauthi. It is like snake thing. So these people go find a snake nest and they just dump it with milk and eggs and everything inside that. It is actually technically to pray for that snake thing. I don't know what is that exactly about. But I never understood the concept. These people, right, there used to be a nest there, and I used to feel bad for the snake. First of all, snakes never used to be there. But this is what I used to think. If I'm a snake inside, and someone comes and just dumps milk, and not one person, one after another, you're flooding the entire nest with milk. On top of it, you're throwing eggs inside. I don't know who told bloody that snakes eat eggs, and not one or two eggs. End of the day, there are like 50, 60 eggs dumped inside. The snake would have died inside. I used to tell my mom that on here, why are you guys doing this? Why you're torching the? You said, hey, don't talk like that to about the god and all. I said, यार God क्या है? Logic समझ में नहीं आ रहा है. You're putting like bloody 30, 40 liters of milk and you're putting 50, 60 eggs. The snake is going to die. You're not praying God, just your obsession with putting it. Mom is like, don't talk like this. That, standard stuff. And then someone is actually smart. What these people do, right? Then I noticed something. After this festival gets over, after 2 days, you will find a lot of people selling eggs, which are little brownish in color, and they sell it for half the cost. And I used to wonder, like, bloody, why are these people selling eggs for half the cost? Where did I get these eggs actually from? And then I realized most of these nests, right, are man-made. Nothing is natural there. And I have this thing came in the news also. So they build this nest, the big one, right, and they have an underground thing there. They don't can't collect the milk, but they put some grass and everything there. So they just put all the eggs and everything. You can just dig it here and open this and remove all the eggs. So people have started creating artificial, the sneaker thing, so that people will put eggs and everything, and you get those eggs. And literally, they must have imagine at least 500 to 600 families go there, and in every nest they put one egg. One person has to put one egg. So each family is putting like 8 to 7 eggs, and there are like 400 to 500 families. You're talking about 2,000 eggs. That time, eggs used to be like 2 rupees per egg, and they used to sell it for 1 rupee. So you made a decent amount of money without doing anything. Anyways, so a lot of things. I and my mom always used to fight. My mom used to say, on January 1st or Ganapati Puja time, if you study today, you will study throughout the year. I used to say, give me 10 rupees today, then you'll give me 10 rupees every day. Well, I think she's like, you talk all logics and all. I said, yeah, if you're saying something, make some sense. So we always used to have a fight. So if you take an ant nest, right, the reason they build that top thing, it's actually a wind tunnel, getting it? So if you actually see an ant nest, now it kind of, I'll try my best to do draw. You're getting it. They have cabins, like, they have empty spaces like this. Something like this. I'm just drawing a very simple version of it. So we have one exit here, one entry here. So the higher it goes, you must have noticed it. The higher the building, the wind blows more. So here, if you take the pressure is P1 and here the pressure is P naught, P naught is greater than P1. So because of this, what will happen? The air will go inside from here. It creates actually ventilation inside. Think about it. Even this ants breathe out carbon dioxide. If you don't have ventilation, the entire nest will fill with carbon dioxide. They suffocate and die. You need to have a ventilation. And the deeper the nest, the higher the tower. So if you see 3 meters long termite hill, you can be sure that nest is like 5 to 6 meters deep. Getting it? So ants actually inherently use it. That is the reason if you go and try to destroy this, ants will go mad. They immediately try to build a new one. And ants don't stay in this. And this is a concept actually, right? They use in architecture also. If you ever seen these old houses, right? I don't know if you have seen the old houses, na? Maybe not in India, Kerala, maybe you can see these houses, right? They look like a rectangle kind of thing, like a square with all four doors on every side. Seen it in movies and all, right? In the middle, you have a corridor kind of thing. Houses like this. And if you see, right, what they do now, they make this house really tall in the middle. So 4 or 5 floors. This actually becomes a wind tunnel. The moment you open the door, wind is blowing like this. This is actually a way to design. People have actually taken up this design in skyscrapers also. It reduces your power bill. It gives you an ventilation. There is one, building near my thing. These people, right? They built 8 towers. I think they must have built it accidentally or something. Big one, 40 floors each, eight towers. So this thing, right, kind of becomes like a cylinder kind of thing, wind tunnel. Anytime you go there, you will see wind is blowing non-stop. So it actually kind of creates a lot of effects. So that is there. So that is our Anka thing. So and if you see our famous aeroplane wings, aeroplanes work based on this. This also can be numerical. So plane ka wings are designed in such a way you have a different speed on the top and the bottom. So this is V1, this is V2, this is P1, and this is P2. So P1 plus half rho V1 square is P2 plus half rho V2 square. So the force on the wing, F thrust, is P1 minus P2 into area of the wing. So this is the reason, right? Your planes need a speed of almost 180 kilometers per hour to take off from the thing. So when your actual plane is taking off, you're reaching a speed of 180 to 200 kilometers per hour. So this guy will be half rho V2 square minus V1 square. Remember, this is the density of air into this is the into area of the wing. This will be like a numerical. Directly, they'll give the numbers. You have to put it there. So there, if you see this, literally this thing, right? You can see from anthills to arteries to flying cars. There you can see it multiple things. So this is the Magnus effect. Has a lot of applications. One second. I think I'm not the co-host. Look at this.
Recently, some friends of mine went to the Gordon Dam in Tasmania, which is 126.5 meters
That's our dam, 126 meters.
or 415 feet high. Then they dropped a basketball over the
So they took a basketball, they just dropped it normally.
edge. You can see that the basketball gets pushed around a bit by the breeze, but it lands basically right below where it was dropped. Now watch what happens when they drop another
Getting it, so it almost fell at the same place. But if you give it a little spin, remember I told you if you give a spin, you get a thrust.
basketball, but this time with a bit of backspin.
Whoa, look at that go! That's incredible.
Did you see how far it went? It got a horizontal push and this thing just took a flight. There, you can see how far it is now. So it's all because of that one spin, everything changed.
This is Brett who just threw it.
Right, and look at this thing, huh? Look at that again, huh? Slow motion. Did you see how did he kick the ball? The ball was kicked to the right. Can you see the ball? It's on the right hand side. And then see, it takes a turn and goes inside. Did you see that? That's a banana shot. See that again.
So you want to learn how to.
The first one is more clear actually. You can clearly see hits and hits. So you want to see more? There's a guy called Robert Carlos, Brazilian footballer. Someone is there. You can't see this clearly. This guy hits really fast. So it's like this. There are people standing in front of the goalpost and 35 meters it seems. You can't see from this angle, but look at from here. You can clearly see this thing. So you want to hit straight, but he's hitting to the right. The ball has gone to the right. Can you see the ball? Then ball is still going to the right. Then ball is still going to the right. And did you see ball took a turn to the left? The video is a little blurred, but I hope you saw that. It went.
That is quite a magnificent free kick. I'm not so sure we'll see one better than that. But
So that's a banana shot. Getting it? And then look at this. We have a flying car. You need always a little jump and this thing goes off. This you can see more clearly. There. It becomes an aeroplane. मजा आता है ना ऐसा cars full braking and dancing and flying and this is how it looks from inside. I'll send this in the group. You can have a look at this. And then let's see one last one here. The ant hill. So there we have a small ant hill. So someone started pouring liquid aluminum into it, molten. I know it's an evil thing to do, but then for the greater good of science, we will kill some ants. So as you keep pouring, it is going on. So the idea is this. So whatever empty spaces are there inside will be filled with this aluminum. So the final cast you get is actually the shape of the ant nest inside. 4 ants must have died. So for ants, you must be looking like Thanos. Then you waited for it to cool down, then you remove the sand, then you take it out, put some water, clean it, polish it a bit. The final thing is almost like 9 kgs. This is how the final shape looks. Nice, no? It looks like an art piece. But did you see? Upper there's only like one entrance, and niche dekha, it is how it is, the whole thing. This is how complicated ant nests look actually. So they must have killed at least some like a few lakh ants, but so the world's largest ant colonies, right, are actually in Africa. So they did find one super colony there. Same thing, instead of aluminum, they're putting liquid concrete now.
The amount of cement required is extraordinary. For 3 days, they kept pouring until 10 tons of cement had disappeared.
10 tons
down
of
the
cement was
tubes.
poured inside.
They,
And then they started digging for 3 floors.
the
And this is how they found the nest. So look at this thing. So every empty space is filled with cement. So the thing which you're seeing around, right, that used to be the empty space. And that rod kind of things, you can see branches, those are the pathways. Isn't it? So that is how the hand nest used to be.
And rubbish pits.
It's like a city only. Like
The
there are like
tunnels are
rooms and there's a
designed to
road
ensure
connecting.
good ventilation and provide the shortest transport routes. Everything looks like it has been designed by an architect, a single mind. But of course that isn't true.
So these colonies have estimated almost 7 to 8 billion ants. So that's the Magnus effect. So after this, we have small concepts are there. One is the venturimeter and siphon. We will see that in the next class. I think it'll like another 20-25 minutes. We'll wrap up that and then we'll continue with the viscosity after this. Okay, with that, we'll wrap up for the day. Right. So any doubts, anything you can stay back and ask. We will catch up on Thursday at 5:30 again, as usual. So